In this video, we're going to get some practice calculating the test statistic and estimating the p-value for a couple different hypothesis tests. We've seen this process before when we were doing hypothesis testing for proportions and for chi-square tests for independence in Chapter 6. The main difference here is that we're going to be looking at population means rather than proportions or tests for independence. That will mean that our formulas will change just a little bit, but for the most part, it should feel pretty familiar to the types of problems that we've seen. So just like with our other problems, I need to start off by finding my standard error. I'm going to find my test statistic first, and then once I have that, I'll use that to estimate my p-value. Before I can calculate the test statistic, though, I need to find the standard error. So I need to find the standard error for this particular hypothesis test. And from the central limit theorem for means, we know that the standard error is s divided by square root of n. So this information should either be provided to you in the problem, or we may need to use our graphing calculator to find the summary statistics like the sample mean and the sample standard deviation. We'll see an example like that coming up here in a hypothesis test in a little bit, but for now we're just going to use the information that's provided. So S, it tells me, is 3.1 divided by the square root of n. Remember, that's my sample size, is 35. So I'm going to grab my calculator over here, 3.1 divided by square root of 35, and I ended up with 0.524. We'll go ahead and round to 3 decimal places here. And there's our standard error. There's our first step. Once we have that, we can go and calculate our test statistics. So we need to calculate our test stat. Now, the thing that we want to remember here, and I always like to do this, is to remind myself, oh, we're going to be using the t-distribution because we're talking about population means rather than proportions. That means that my test statistic is going to be a t-value and not a z-score or something like that. So I always like to just make a little note here that we're going to be using t rather than z or anything else. So my test statistic will be a t-score. In this case, the way that I calculate it, I want x bar, my sample mean, minus mu naught, which is the number that's from my null and alternative hypothesis, divided by my standard error. So we'll start with the easy stuff first. X bar, that was provided to us right here as 4.25. So X bar is 4.25. Next, we got to find mu naught. This is the number that we talk about in our null and alternative hypothesis. So you have to have your null and alternative hypotheses set up before we can calculate the test statistic. So I look right here. It tells me that my population mean is assumed to be 5 in my null hypothesis. So my null hypothesis, or excuse me, my null value will be 5. So I have 4.25 minus 5 divided by my standard error, which we just calculated last time to be 0.524. And again, I'll grab my calculator here. 4.25 minus 5 divided by 0.524. And I ended up with negative 1.431. So we've got negative 1.431. Again, just reminding ourselves that we're going to be using the t-distribution rather than z. So there's the first part. I have my test statistic. Here's the first part of my answer. The second part is to estimate the p-value. In order to estimate the p-value, I need the test statistic, which I just found, but the other thing that I'm going to have to find is my degrees of freedom, and that's calculated the same way it was when we were looking at confidence intervals. So degrees of freedom is n minus 1, so in this case 35 minus 1 gives me 34. So we're going to need to know that piece of information too when it comes to calculating my my p-value or estimating my p-value. Now, similarly to what we saw in chi-square distributions, because we have technically infinitely many degrees of freedom are possible, that's a lot of different distributions that we can't list every single possible case. So what we're going to see is we're going to see some estimation happening here. We're going to get an idea of what our p-value is, and that is enough to make our decision, just like we saw back in the the section on chi-square test for independence, where we can say, okay, well, our p-value is in this range or it's greater than this value. And at the end of the day, that's all we really need in order to make our decision at the end of our problem. So I'm going to hop over to my t-table right here. We will need that. So going over to my t-table, we said we had 34 degrees of freedom. So we're looking at this row right here. And the other thing that I'm going to make a note of, our t-score, we said t was equal to negative 1.431. Now, first thing I'll notice is if I'm looking at this is none of these values are negative. They're all positive. For the purposes of calculating the p-value or estimating the p-value, we're going to go ahead and if we have a negative test statistic, we're just going to change the sign to make it positive. So 1.431. So if you're answering the question, what is the test statistic? Then yes, I want to use this negative 1.431. But when it comes time to calculating the p-value, we don't really care so much about the negative sign. So I want to figure out where this 1.431 lives in relation to my other t-values that I'm seeing in this table. And I see here's 1.31 and 1.69. 1.43 is going to live somewhere between those two values. So I am almost there. I almost have an idea of my p-value. The last thing that I need to do, though, is I need to determine what type of test we're doing, because we really have kind of two different possible ranges. It's either between 0.1 and 0.05 or between 0.1 and 0.2. And what that's going to depend on is whether we're doing a one-tailed test or a two-tailed test. In order to make that determination, we have to look back at our alternative hypothesis. This is another reason why we have to have that set up in order to calculate our p-value, is we need to know what type of test we're doing. So I'm going to look back here. In this case, if I look at my alternative hypothesis, we'll highlight this in red here, we're looking at this right here. It says the population mean is less than 5. So in particular, this is a left-tailed test, but for our purposes, we don't really care so much about that. We just care that we're talking about one side of our distribution, which means that this is a one-tailed test. So it's a one-tailed test, which tells me which part of my t-table I'm looking at. So hopping back to my t-table one final time for this problem, we said we were doing a one-tailed test, which means we're looking at these values. That means that my p-value is going to be somewhere between 0.05 and 0.1. So I can't say exactly what it is with these tools, but I can say that the p-value is between 0.05 and 0.1. And that's enough to help me make my decision. If I had my level of significance alpha, at this point I could decide, okay, do I reject H0 or do not reject H0? And that's all I really need at the end of the day for these particular problems. So I have my test statistic right here, and here is my estimation for my p-value. So we have one more to do. I would encourage you to pause the video at this point and try and calculate what is my standard error, what is my test statistic, and see if you can find that estimate for the p-value here. So go ahead and pause it real quick and then come back, check your answer in just a moment. All right, congratulations, you've tried the problem. So now we're gonna go ahead and calculate our test statistic. So, excuse me, before I do that, I need my standard error. So standard error we said was S divided by square root of n. So S, it tells me, is 4.1. So 4.1 divided by square root of 58. So let's grab my calculator. 4.1 divided by radical 58. I ended up with 0.538. We'll round to 3 decimal places here. So I've got my standard error. Once I have that, I can go and find my test statistic. So my test stat is a t-score. I'm going to be using my t-distribution. And the formula for that is x bar minus mu naught divided by our standard error. So x bar coming from our sample mean. So we're looking at this guy right here for our x bar. That is 73.8. So 73.8 minus my mu naught. That number is going to come from our null and alternative hypothesis. So remember, I'm looking at the null hypothesis. Here in this case, it says mu is equal to 73. So minus 73 for my mu naught divided by my standard error. We just calculated that as 0.538. And let's go ahead and work that out. I have 73.8 minus 73 divided by 0.538. And this time around, I ended up with a positive 1.487. So here, first of all, is my test statistic, a positive 1.487. That's good. I need that. I'm going to do two other things before I look over at my t-table in order to get the p-value estimation. First thing I need, remember, is my degrees of freedom. I'm looking at this value here, n. I know that degrees of freedom is n minus 1, so that would be 58 minus 1, giving me 57 degrees of freedom. So my degrees of freedom are 57. We'll need that. The other thing I'm going to take a quick note of here is the type of test we're doing. Looking at my alternative hypothesis, this says mu is not equal to 73, which means that this is a two-tailed test. So this problem is a two-tailed test, which tells me what row of p-values I'm looking at in order to make that estimation. So at this point, I have everything I need. I kind of need all three pieces of information. I have to know what kind of test we're doing, I have to know the test statistic, and I have to know the degrees of freedom if I'm going to go and calculate my p-value. So let's hop over to our t-table at this point, and let's erase what we have right here just so we can start fresh. So we had said degrees of freedom was 57. Our test statistic was t equals 1.487, and this is a two-tailed test. So, okay, we're looking, first of all, let's find our degrees of freedom. 57 does not appear right here. So remember, it's the same kind of rule that we talked about for confidence intervals, where we're not allowed to go up for degrees of freedom. We have to go down, which means we're going to be using the degrees of freedom of 50 right here for our problem. And then I'm going to look for 1.487 within my row, and in this case 1.487 is already positive. I don't need to change the sign like I did last time. 1.487 is going to live somewhere between 1.30 and 1.68, so I'm looking at that range. And then finally, we established that we're looking at a two-tailed test. We're looking at this row right here, which means that my p-value will be somewhere between 0.2 and 0.1. So to hop back and write down my final answer, my p-value is between 0.1 and 0.2. So there we go. There is our p-value. This is going to be a really critical